How can open source help you do IoT right? That's the question I asked Sam and Daniel from Toradex. Having made the observation that most embedded solutions and their discussions revolved around the software aspects, they decided to focus on developing system on modules to help streamline the hardware part, which allows customers to focus on adding value on the software part. And to make things even simpler for you, they offer an open source stack that goes from the Yocto-based Torizon OS all the way up to DevTools and the cloud. So check out this interview to discover how well open source and embedded fit together. Hi everyone, this is the IoT Show. I'm Olivier, your host. We are in Seattle in the Toradex offices, and I'm here with Daniel and Sam. Folks, how are you doing?
Great, thanks for having us.
Well, you are having me, technically speaking, because I'm drinking your coffee in your cups. Awesome. Before we get into the topic of today, which is discussing open source and embedded and how they work together and how Toradex is applying best practices and leveraging open source in the world of embedded, why don't you introduce yourself? Let's start with you, Daniel.
Okay, yeah. My name is Daniel Lang. I'm now the Chief Marketing Officer for Toradex, but I'm with Toradex for about 18 years, and my background is in electrical engineering, software development, before I moved more to marketing and product management.
Thanks, Daniel. And my name is Sam Imgruth. I'm the CEO here at Toradex. I also joined the company about 17 years ago as a development engineer and worked my way up to now leading the company globally, which is a super exciting part of my career.
So I know we have something in common, all of us, which is a bit sad, which is Windows CE. So I think we got to know each other because I was at Microsoft working on evangelizing Windows embedded to developers. And I know I engaged with you, Sam, and other people of the team as well in the past, the Win CE, RIP. But there's good news. You guys are still doing a lot of interesting things. So how about Sam or Daniel, one of you or the two of you, give us a quick introduction of Toradex?
Yeah, maybe Daniel. Okay, I'll take it. So what do we do here at Toradex? If you're building an embedded device, an IoT device, or any kind of computer that's used in an industrial environment, you will deal with chips and connectors and boards. But there's multiple options how you can do that. Either you build a fully custom system, you're buying something completely off the shelf. But what we do at Toradex, we actually build this system of modules, which encapsulate all the complexity that a computer system brings with it. It has the processor, the memory, the flash, all the connectivity, all the high-speed signals are encapsulated. Mm-hmm. And then you can just focus on customizing your system with a carrier board that you can build. And so that's really what we do at Toradex. So we help all our customers that build IoT, industrial, medical, transportation, you name it, devices built or powered by these kind of small computer cards. And it looks like hardware, but a lot of it is actually software. And I guess we get to talk a little bit about this today.
Yeah, exactly. I think one of the first things that we discussed when we're preparing for this recording here was the trends of the industry, right? How you guys came to focusing on SOMs, right? And this notion, I think it's you, Sam, or I don't know, you, Daniel, saying, hey, everything begins with software. And that's something that was super interesting. Tell me more about what you have seen as trends in the last decade when it comes to hardware for embedded systems.
Yeah, so when we started at the beginning, people were really focusing on the hardware. So they started about, what kind of SoC do I need? What kind of interface? And very, very close to the hardware. And what we really saw in the last couple of years is that software gets more and more important. More of the functionality, more of the value of the end products goes into the software. So now we see kind of a change so that the people who define the software, who define the functionality in the software, defining what they need. And then from there, it trickles down what kind of hardware I need, what kind of features I need there. Okay. So that we kind of see a reverse how people begin to engineer a product.
Okay. And what about the modularity of software, right? Because we're talking here about something that looks monolithic, right? The chip, everything on that SOM here. Is it the same thing for the software part where things are like becoming monolithic there, or on the contrary, more and more modular thanks to the RTOSs and so on?
Yeah, also on the software, people want to have something very modular, because these products are used in so many different applications, and each application has different requirements. And medical is maybe different from industrial automation. So the software is very modular. Another topic where modality is very important is to optimize the product. So they're sold in volumes. So you want to make sure you do not waste resources. You want to keep your attack vectors low and so far. So software is optimized to fit on an embedded platform.
Yeah.
And then we are actually at Toradex really also working on making it modular for our customers, so they can pull in different frameworks, AI frameworks, UI frameworks, and they can easily integrate that. So we even go so far using containerization, software containerization, which really help people to easily exchange that, to comparize, put stuff in a small box so you can exchange them, makes it much easier in maintenance, and yeah.
So you get software as even more modular because you have that integration of the hardware into the SOMs. I like that.
Exactly, yes. And also our SOMs, even they're one piece, you can actually modelize them. So for example, this one here has a Wi-Fi, Bluetooth on it, so you can add that, leave that away. And then these modules are pin compatible. Okay. So you can basically design a device and maybe do a low end, a high end, or you can upgrade over time. So you can keep your software. But for example, you just need to be faster. You have a bigger screen, so you can just exchange the module with one, maybe with a bigger GPU. So it's very modular, and so you can improve over time, adjust to market demands, and so on.
I love that. I love that a lot. So one of the things that you guys have been being very vocal about, and I like that, is open source, right? Open source, as in it's a great tool for doing IoT right, for doing embedded software right. Tell me more about that. Why do you think open source is so important for embedded development these days?
Yeah, I think it also has really to do with that shift of the community. I mean, we're selling a hardware, and the customer, like our customers, they have to make a lot of decision on their device design that's out of control for us. And, with these different peripherals that customers are adding, and then the different processor platform that they want to use these peripherals with, the software is what glues it all together. And if you use closed software that maybe just comes from one vendor, and I mean, the chip crisis was a very good example. You had to maybe do a redesign and use another peripheral chip very quickly. If you're now locked into some kind of closed source downstream driver from that peripheral, you may be out of luck porting your software over very quickly. So one thing at Toradex that we really focus is we have this initiative at the company where we have a mainline first or an open source first initiative. So in the system design, what we're doing is we make sure that all the processor vendors we work with, the peripheral providers that we work with, that they have some kind of open source strategy, because it then also makes our customer's life much easier. And it goes even further. When you want to maintain these devices for like 10 plus years, if you have something closed, I mean, we don't even know if that company is still going to be around to support it. If it's mainline and open source, there's a community around to continue to support that, or you can keep that up yourself. So it's a lot in that longevity and just the kind of the guarantee that the customer gets that he's not going to be locked out in the end of the day when he needs to maybe patch his software or there's a security vulnerability. So open source really comes in big there as a play.
Yeah, that makes sense. And we mentioned also, so there's this notion of being future-proof, right? And being able to own the code because it's open source at the end of the day. But there are also aspects as well. Regulation is one of them. You mentioned updates, AI that is evolving and that you need to integrate. So these are all arguments in favor of open source, right? How does it look like from your perspective? You mentioned software open source. But there's also a notion of hardware open source and all the way up the stack. How does open source look like for Toradex?
Yeah, so as Sam already said, it's very, very important for us. And as you also now mentioned, for example, cybersecurity. So there's new rules. Yeah. So it has to be secure. It has to be proven secure. So people sometimes need to review code, which is much easier with open source. And then also over time, you need to be able to patch that. So there will be law that you patch. So you need a very secure and reliable open, update system, but you also need the software being able to update that. And if it's maybe you have a weird peripheral where maybe the vendor is not providing update for that, and there's maybe a security patch in there, you're basically not able to comply with the law, right? So sometimes it really forces you there. And also on the hardware, we are very open. So you see here a lot of boards, and there is really we help our customer to design their own carrier boards. So they actually use these boards here as a starting point, and these boards are manufactured. You can buy them. So they know they have a good base to start, and then they can add, delete things and stuff like that. So there it's mostly about reducing time to market, increasing the developer experience, and reducing risk. That's something could be.
I would add though, really the full stack approach. So open hardware for us really means is we provide you all the schematics, all the circuitry that we have tested. So it reduces the risk, but it also allows you that maintainability, or we even provide you, because we sell all these boards, we test this. Like all our software releases are tested from the hardware to the OS layer, to the application layer. So that is just, I mean, at the end of the day, it's the same benefit you get on the software that you learn, whether it's bug fixes, whether it's quicker time to market, easier maintenance. It applies to both, whether it's in the hardware or on the software side.
Yeah. So that triggers a question, a bit provocative here on purpose. So here we're talking about a model where customers need to have their own PCBs, their own custom form factor.
That's
devices. Right. But we're seeing a trend, or I don't know if it's a trend, actually, you tell me if I'm right or wrong. I personally, I'm skeptical about it, but some people say there's a trend to adopt SBCs, to adopt things that are at a high level and kind of like make up for, for the lack of flexibility in form factor with enclosures and so on. Like pick a Raspberry Pi.
That's right.
And just like put it into whatever enclosure and make it work. Do you see the market going towards a model where it's going to go beyond the SOMs and customers will want to integrate something like a Raspberry Pi format and it's just like off the shelves and integrate it with a software stack without having to create their own PCBs? Or do we will still have that need for custom PCBs, custom form factors in the future?
I mean, maybe I start. I would say it's really both. I mean, we see both. For sure, Raspberry Pi was a huge I would say, disruptor for some of the custom applications, but it's also been a huge educational part to bring people into this industry that previously they were locked out, right, to even get access to this kind of hardware. So we see, I mean, if you look at these applications, there is a range from like a few 500 pieces that some of our customers buy up to 100,000, and then it goes into like half millions. And so all of this, the crazy thing about our industry and embedded is, it's so diverse, it's so heterogeneous. There are some people that can maybe take a Raspberry Pi, put it in a box and hide it behind one of their medical devices. That was fine. But there's other medical company that want like this unique customized device design where maybe they need an extra USB port or maybe they need an extra couple IOs. And then they want to certify the whole system with these changes and they want to own it. And that's when the customization comes in. And then you have very high volume customers. They say, I don't even want to have two boards or off the shelf. I want to make my full custom design. And that you see usually in the very high volumes when it goes into several hundred thousands. So yeah, I would say it's a very heterogeneous. It's not a yes and no answer. There's actually been a good trend that Raspberry Pi brought to our industry, but we still see very huge demand for these customized systems.
Yeah, and you really see also a lot of people who originally did everything themselves. So they would just buy the SoC, the RAM, and then design everything. And we really now see a shift that more and more these people, now they go to a module, right? Before they go to a single board computer, right? So the first step is really that people who did fully custom designs, they go to a module. So there is more standardization.
Yeah. And we're trying to kill the fully custom one, right? Because
yeah, I mean, we still feel it's possible in very high volume, but sometimes people do not understand the total cost. So there is a lot. If you do a design completely by yourself, there's so many hidden costs. It's not just the BOM. You need to certify it. Stuff goes wrong. You need software support. You need to maintain your software support. Components go end of life. You need to replace that and all of that. And with a system on module, you simplify that heavily.
And from my perspective, I think only the very big ones that do extra big volumes, the Samsungs, the Apple, are able to do their custom designs in the house, right?
It depends what engineering capability you have at your company too. You know, if you look at small to medium-sized businesses, they often don't have the engineering expertise. Then they have to outsource that design. Well, that's good for once, but then they still have to maintain that outsourced design over 10 years. And so that this total cost of ownership for my embedded computing platform is something we try to educate our customers very frequently. And I think it's really, for one, it works, for the other, maybe not.
Yeah. So software on embedded is not easy, right? We can like put it in any kind of way. It's not simple today. What are you guys offering beyond that notion of a SOM and that integration? What are you guys offering in your stack that help customer go from, hey, here's my specs, my requirements, to here's my working device?
Yeah, so really, going back to the beginning, it really started with Windows CE, right? Like way back there, exactly, a long time ago. And there, our selling point was really making that even much easier. You probably know Platform Builder, but that was already too complicated for many of our customers, so we simplify that. In the meantime, of course, it's mostly Linux, and we do a lot of work with the Yocto project. So people who know the Yocto project, we work on BSP, making sure the drivers work well, they're tested, and so on. But even with the Yocto project, we feel it's too complicated for many of our customers, especially people coming from Windows, Android, people who more like to focus on application development and not like building an operating system. Because the Yocto project, for the people who do not know, that's a project which helps you building your own Linux distribution. So it helps you really customize your Linux for your device, save all the memory. So it's very, very good, and we highly support that. But it's maybe too complex for many for many people who just want to focus on their product. And so there we also provide a Linux distribution called Torizon OS. And Torizon OS is fully built with the Yocto project. And it's, of course, fully open. So you can actually take Torizon as a reference platform to start your own Yocto customization, if you like. Or you can just take it as it is, as we are testing it very frequently, and it's patched and works very well. And it also comes with over-the-air update and remote access and device monitoring. And all this, why we added that, is because basically everybody needs now. Like when we started, over-the-air update is pretty fancy, but now basically everybody needs it. And also with the new security regulations, the push to implement that is getting more and more. So we just said we do it for all of our
I'm hearing that more and more, this need for over-the-air updates that use indeed to be a fancy thing, something that customers will say, no, I'm actually distributing that thing. It's going to be living for 20 years, never updated. And that was right and true at the time where these devices were not connected.
Correct.
So they were not exposed to threats. They were working, do one thing, do it well, that's it. Now that we are exposing these devices that have more functionality to the internet, now troubles happen, and people try and access. And there's value for some people, ransomware, like industrial spying, states with bad intentions. But so over-the-air updates definitely is one. So is part of the offer, so Torizon as the OS, is there a cloud service that comes with it?
Exactly. So we also offer a cloud service we call Torizon Cloud, where we basically offer all the hosted parts, so to do the updates, to do the remote access, and so on. So you can really focus on your application, and you don't need to deal with that. But also here we follow a standard, Optane standard. It's a Linux cloud, native cloud foundation project. So we follow that. So you can build your own cloud. So you're not locked in. But if you say, hey, I'd rather focus on my application, on my added value, but I need this functionality, we can help our customers.
So I can see the open source influence, from down there all the way up to the cloud. I like that.
Yeah, it's been really a journey for us. I mean, our goal at Toradex is really to make embedded computing easy. We just want to help customers being successful in the market as quickly as possible and let them just focus on their application. Because all these customers, they don't want to build a computer system. They want to build a device that is very specialized for their market, for their application. and they want to focus on that. That's where their value add is with what they're doing. And so pretty much all our work at Toradex that we do is focused around that ease of use, the simplification of these complex computer systems, and letting the customer just deal with whatever he knows and what he's good at. And the rest they should leave up to us or someone who helps them in the process.
Yeah.
That's really the goal for us, right?
Yeah. Everyone should add the value what they're good at.
Yeah.
Right? And contribute to that.
That's kind of our mission at Toradex, I would say. Yeah.
I like that. No, I think the business of IoT embedded and at large, digital transformation with the other technology that come into play, I think is really about integration of parts, right? Integration of a piece of hardware with the right software, the right connectivity, the right security stack, the right cloud part, and having experts are able to focus on their part, make it interoperable, open source standards, and allowing partners to be good at it and integrate that. I think that's where we're going.
Yeah. So, you bring up an interesting point, Olivier, because partners. And one thing that we're also quite passionate about is the ecosystem, the partner ecosystem that we built. I mean, yes, of course, we sell hardware and we have a BSP and we have our own distribution, but it doesn't stop there. I mean, we have in our ecosystem, we have different software partners. If you want to use Android or, if you want to use or need help building a carrier board, I mean, we really try to offer all these services at the fingertip of the customer. So really to support them through the process of this complex, because you said, embedded IoT is not easy. Yeah, right. And so we really want to fill the gaps wherever possible.
Yeah. And the modularity you mentioned at the beginning really comes there in, right? So we have machine learning frameworks, UI frameworks, cameras, displays, all in the ecosystem, so you can put it together so it works your application.
Yeah,
that's right.
I love it. So what's your recommendation for someone who wants to learn more about Toradex? Like, do you have something that people can go look at, try out, get hardware, etc.? What's the next step for them?
Yeah, I really recommend them to go to our website. Okay. And we are actually a little bit, almost famous for our documentation. Okay. So we know that also people in the industry, maybe not using our product, use our documentation. As this is very, very important for us. We're very passionate about. So definitely go there. Ideally get some hardware. There's a very nice quick start guide. Yeah. You can, you can go over it. And then for Torizon, we were talking about that. We're talking a lot about open source. So this software is not just designed for Toradex hardware. Okay. It also works on other hardware. So even if you have a Raspberry Pi or you have an x86 or you even have just an emulator, you can already try out Torizon. There is Torizon.io, and then there's an open source thing. You can go there and you can learn more about the open source projects in there, how we build it, all the different sub-projects we use and support. And then you can also see a lot of open hardware. You can try it out, and you can try it out maybe even on the new hardware. Yep. We don't do it, and we are very happy for anybody who likes to contribute and interact with our engineers.
I was about to say, because you guys are very much into open source all across the stack, your engineers are on GitHub, they're out there, they're reachable, they are answering. Actually, I was looking at some of the forums and so on. They're on top of it. So you know what to do. Go check out what's going on at Toradex with Torizon and all the tools. Both of you, thanks a lot. Thanks for the coffee.
Thanks, Olivier, for coming.
Appreciate it.
Yeah, thanks
Likewise.
so much. Thank you.
Talk to you soon. Bye.
Thank you. Bye-bye.